All right, guys. So the next unit is on the next unit is on logic and reasoning, as well as geometry. Okay, so the first lesson is on something called inductive reasoning and counterexamples. Okay, so inductive reasoning. Actually, you know what? Probably best to just kind of start off with this example, and then I'll kind of explain the process. All right. So with this first example, what you notice here is I typed up 4 different equations. 3 plus 5 equals 8, 5 plus 5 equals 10, 11 plus 7 equals 18, 41 plus 11 equals 52. All right, so based on these 4 equations, we can hopefully kind of see a pattern or draw a conclusion. Okay, so if you notice here, I have an odd number, and an odd number equals an even. Odd plus odd is even, odd plus odd is even, odd plus odd is even. All right, so the conjecture or conclusion. All right. So the conjecture, or in other words, the conclusion, is that an odd number plus an odd number is going to equal even number. Okay. Or in other words, the sum of 2 odd numbers is always even. Okay. So the process of drawing this conclusion is called inductive reasoning. Okay. So as a definition, inductive reasoning is drawing a conclusion based on observation. Okay, so that's inductive reasoning. All right, so when we observe something, and then we kind of draw a conclusion based on the observation. So in this case, again, in this example, we have odd plus odd is equal to even. All right, and these 4 equations kind of show that. All right, but just because we have 4 equations here does not actually mean that it's true. Right, we're just kind of observing off it with 4 of these examples. Now, I could possibly keep writing equations like odd plus odd and just noticing that it's even. However, that's not going to prove that it's true. Okay, so to prove that it's true, it's actually what we're going to be looking at in the next lesson, called deductive reasoning. All right, but I'm just going to define it right now. Okay, so we have inductive reasoning, and we also have deductive reasoning. All right. Oh man, sorry about that. It's got to be a way to disable this keyboard somehow. I'll just wait till it pops up again. All right, so deductive reasoning is when we prove a conjecture is true for all cases. All right, so that's basically kind of like the process. All right, so we make an observation, we draw a conclusion or a conjecture. So these 2 words are interchangeable, conjecture and conclusion. And that process is called inductive reasoning. Now, once we draw a conclusion, what we also want to do, in most cases, is we actually want to prove that it's true. And that process is actually called deductive reasoning, which is what we'll look into deeper in the next lesson. All right. Now, that being said, I'm just going to kind of show you a quick way for me to prove that odd plus odd is even. All right. So this is basically my proof. And again, this process is, sorry, turn this off. Right here. Whatever. All right. So I'm going to prove it. Okay. So now this is deductive reasoning. So in order to prove that odd plus odd is even, I'm going to do it visually. All right. So what I'm going to do here is I'm going to take I'm going to take let's just say I have a piece of wood. Let's say I have two pieces of wood. All right. Now, if I make one cut this way and one cut this way, no matter how many times I cut it this way, I'm going to have an even number of pieces, right? Because it's like cut down the middle on one way, but then no matter how many times I slice it the other way, I'm going to have an even number of pieces. Same with this side over here. Okay. All right, so I just drew a random number of slashes up and down, but as long as there's only one cut left to right, I'm going to have an even number of pieces. Now, if I do that, however, if I add one piece to this, so let's just say here, and then on this piece of wood, I add another piece, then if I have an even plus one, that's going to be odd, right? So the first block here, it represents an odd number because I have even plus one. This is also odd. Now, if we actually visualize putting this thing together, all right, so maybe with the arrow here, just going to draw like putting these two pieces together, then it's going to fit flush, right? And you can probably see that as a result, we'll have like one big, we put it together, got one big thing here, and we'll just have a bunch of slices this way. Okay, so imagine putting these two together, then that means that even number plus even number, since this is going to fit flush, odd plus odd is going to equal even. All right. So hopefully this kind of proves that odd plus odd is even, right? No matter what, in all cases. So this process here would be deductive reasoning. And again, that's in the next lesson, right? So just for today, a couple things I want to point out is, conjecture is the same as a conclusion. All right, so based on observation, and that's inductive reasoning, right? Now, the other thing I want to cover in today's lesson is counterexamples. So I'm going to scroll down to this one here. So I'm going to use this as an example. All right, so what a counterexample is. Oh, it's got to be a way to turn this off. All right. So a counterexample is basically an example that shows a conjecture is false. All right, so let's say I come up with a conjecture and I want to show that it's false. The other thing to realize is that you only need one. Right? You only need one counterexample to show that a conjecture is false. Okay, so for this one here, this is my example. I have a conjecture that all numbers that are multiples of 5 are multiples of 10. Okay, now this conjecture is actually false. And all I would need to do is I need to come up with one example that shows that this is false. Right, so multiples of 5 are, so multiples of 5 are again 5, 10, 15, 20, and so on. All right. Now, all numbers that are multiples of 5, these are not multiples of 10. All right. So I'm just going to circle 5 here is actually a counterexample. 10 would also be a counterexample, but you only need one of these, right? So I'm just going to point at this one here and just say that 15 is a counterexample. Okay, so the key thing here is that, the counterexample is basically an example that shows that a conjecture is false. And so that is, and all you need is one, right? Here I actually have 2, but you actually only just need one. All right. Cool. Yeah. So that's it. That's basically today's lesson. All right. So very short and sweet. That's it. Ciao.